Hello students, welcome back to my next video. It's actually video 10 in this chapter. In last 9 videos, we learnt about electric charge, properties of electric charge and the law, important law, that is Coulomb's law, which deals with the force between two charges and numerical problems. Numerical problems very, very important. Keep solving problems. I have given some 3-4 assignment problems. Some of you have solved and sent me. Some did not. But you have to be solving problems regularly. Then only you can learn concepts of physics clearly, which will help you perform very well in CET NEET examinations. Of course, you will score good marks if you just practice derivations. You do that. Along with that, you keep solving problems. Your performance in CET NEET depends on how you involve yourself in problem solving activities, right? We'll move on with the new topic today, that is electrostatic field. Let's see the concept of electrostatic field. First of all, let's see what your textbook explains about the word field. See, this is what it says. Field is a region. What is field? It is the region of space, the space around a charged object in which another charged object, means particle, experiences its influence. What is that influence? Electric force. This is what you have been learning, right? That region is said to contain electric field or electrostatic field. Once again, you keep this word in mind. The region of space around a charged object in which another charged object experiences its influence. That influence is electrostatic force. The region is said to contain electric field or also called electrostatic field. Why? Usually you consider here in this chapter charge at rest. Students, been learning about charge and its properties and the force between two charges, that is Coulomb's law. Let us suppose there is a charge Q1 here. You bring another charge here, that is say Q2. I use Q1, Q2 like this, big, small. Okay, fine. How do you find force between these two? First of all, you join these two by a line whose distance is r. You learned there is a force between these two. That force is given by Coulomb's law. What is Coulomb's law? F equals to constant K, Q1, Q2 divided by r square. R is the distance, right? What is the direction of the force? If the two charges are positive, direction away. Both are negative, direction away, repulsive. One is positive, the other negative, direction is towards this. That you have been familiar with, learned very well, been learning. Okay. Now the question is, if I place the same charge here, will there be any force? Yes, it experiences force. You think other way around. One charge here, keep another charge, say some Q3. Will there be any force here when this is there? Yes. It interacts with this also. One more point here. There another charge, there will be interaction. Like that, all around in this region, this charge influences other charges. Not only here. It can influence a charge here, anywhere around. That's why a region of space around a charged object in which another charged particle experiences a force. Now, let's come to an example to let you know what is the meaning of field, exact meaning, how you have to think whenever we use the word field, because you use field quite oftenly. Cricket playing field, paddy growing, ragi growing, like that. Field, a general word. English dictionary meaning of the English word field is a little bit different compared to the way we think about the word field. That's why I'll take this as an example. See, students, what is this? A bunch of flower, right? Flowers. See, if I hold it in my hand, I feel even if I close my eyes, I feel the presence of flower. Why? Yes, because of its fragrance, smell, scent. A flower gives out scent, which I smell, right? If I take my nose very close to the flower, more smell. If I am bit away from it, smell is there but less smell. How smell is produced? See, now there is no smell in this region here. Now, if I bring the flower here, that flower influences the region. How? How it influences? See, what happens actually from the petals, the fragrance producing molecules come out. You will learn about all that in biology and some other subjects in detail. Okay, fine. Let's not bother about how it happens. Thing that happens is the fragrance producing molecules come out of the petals. They spread themselves all around, get diffused, have been spread all around. The number density is more here, more smell. Less here, less smell. If I bring my nose here, yes, there is smell. Here, there is smell. Here, there is smell. Here, there is smell. So, all around, there is smell. The smell means the molecules which produce scent, smell, fragrance have spread all around. So, can be called field of smell. What is this? Field of smell. You notice one important point. When you are close to the source, flower is the source of smell. When you are close to it, more smell. Away from it, less smell. Fragrance decreases if you move away. So one thing. Another example, you create some fire over here in this region. Fire. How do you sense fire? By using your hand. Skin has sensation of hotness or coldness. If you take hand close to it, you feel warmth. Bit away, less warmth. Still lesser. Means hotness, busy. ನೀವು ಫೈರ್ ಹತ್ರ ಬಂದರೆ ಜಾಸ್ತಿ ಬಿಸಿ, ದೂರ ಹೋದರೆ ಕಮ್ಮಿ ಬಿಸಿ, ರೈಟ್? ಆ್ಯಂಡ್ ಹೌ ಡು ಯು ನೋ ದಟ್ ವಾರ್ಮ್ನೆಸ್ ಆರ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಹೀಟ್ ಇನ್ ದಿಸ್ ರೀಜನ್? ಥರ್ಮೋಮೀಟರ್. ಇಟ್ ಶೋಸ್ ರೀಡಿಂಗ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಟೆಂಪರೇಚರ್ ಡಿಗ್ರೀಸ್, ರೈಟ್? If you are very close to fire, temperature more. Away from it, temperature less. So, this region now contains the field of temperature, hotness. Other example, see, this is a magnet, right? Magnet or played with magnet, very, very familiar object, right? Now, this magnet, presence of the magnet has changed the configuration of the space around. This is what you have to remember. It changes the properties of the medium when it comes over here at this point. How do you know there is some influence around? Take another magnet or some magnetic material. See, it is influencing, right? There is no physical contact. Notice one thing. There is no physical contact, but this influences this. This influences this, right? If I do the same here, yes, there is influence. Here, influence. Here, influence. Here, influence. So, all around in this region, around this magnet, there is an influence called magnetic field. Magnetic field. Now, our topic is not field of fragrance, not field of temperature, not field of magnetic field or magnetic field. You will learn that in 4th chapter. Our topic is electrostatic field. What is it? Now we have understood the concept of field. What is field? There will be some source which influences the region, and due to that influence, another thing can sense it. In the case of flower influences the region means spreads the molecules of fragrance producing molecules around. My nose can sense it. Similarly, magnet influences the region which can be sensed by another magnet or magnetic material. That's what I mean by field. Field is a region in which an influence can be felt. If it is influence due to a magnet, magnetic field. Influence of a flower, fragrance of flower, that is field of smell, field of fragrance. Similarly, we will see today the electrostatic field. I'll come to an example now. Students, we will see the idea of electric field. What is this? A straw which we used in our previous videos. I have charged it by rubbing with a cloth. You can see the presence of charge here. If I put my hand here at this place, it gets attracted. Here, attraction. Here, attraction. Here, attraction. Everywhere, it influences another body. Means, around this straw, because of its charge, there is an influence. That region of influence is called electric field. Now, if I bring another straw after rubbing with a cloth, right? What do they do? Yes, what is called? Repulsion, right? This is a charged body. This is a charged body. What is the thing that you have to understand? See students, in the absence of the straw, the space had some property. When this straw is brought at this place after charging, because of the charges it has changed the properties of the space. That change in properties of the space is identified by this. This also has got charge. This also has got charge. The influence made by the straw in this region is felt by this because of the charge it has, right? Now, these two interacting each other at a certain distance. There is nothing in between these two, right? Can you see anything coming out of this and entering this? No. There is empty space, seems to be empty. This influences this at a distance. That's why we call the electric force as a action at a distance. Action at a distance. Even gravitational force also. These act at a distance. This is here. There is a influence of this over this, right? There is no physical contact between these two. What is the meaning finally you have to understand? What is the word you have to remember? Due to the charge it has, it influences the space around. That influence is identified by this due to the charge it has got. So, there is interaction between these two via what we call field. So, what is field finally? Finally, field is an influence created by this charged body around the region. That is sensed by another charged body. That interaction between these two is called a force, maybe attractive or repulsive. That's why electric field is a region around a charged object in which another charged object experiences its influence. What is that influence? Electric force. Influence is electric force. Then this region around this is said to contain electric field. This is repulsion. This is attraction. Repulsion, attraction. That is an influence. Right? This is what you have to remember, students. I explained you the concept of field in general and electric field in particular with some examples. I hope you won't forget this. Now we'll move on. Students, now let's come to the definition of electric field. Definition of field always accompanied by a word electric field is optional here in this chapter. Even if you don't write electric or if you don't say electric, it means electric only, electric field. Definition of field means electric field. How it is defined? It is defined as electric force experienced per unit test positive charge at that point. Unit test positive charge at that point. Why it is defined this way? Definition means what? The way you know it, how much force is there at that point is measured in terms of force per unit charge at that point. And if you understand this way, it is called electric field. What is electric field? Defined as electric force experienced per unit test positive charge at that point. Why the word unit? Test positive. We'll come to that shortly. When you measure this way, it is also called by a name electric field strength. Strength, how much strength is there in the field, or intensity value. Generally field, even if you say electric field, it means electric field strength or field intensity, defined as force per electric charge, that too unit test positive charge. Mathematically, E equals to F by Q naught. What is Q naught? Unit test positive charge. Students, to come to this definition, why we think this way? Means electric field as a force per unit charge need to start from the last year's Newton's law of gravity. I'll take up that in just 5 minutes. I'll explain you what you learned last year about Newton's law of gravity. Students, you all know there is force between two masses. There is one mass m1, the other m2. That gravitational force between the two is given by g m1 m2 divided by r square, where r is the separation between these two. Any two masses attract each other with a force this. Now you think of the situation, you consider earth. Radius of the earth is say re, radius re. Mass of the earth m1, that is me. I place another mass just over the surface. You can place anywhere, here, anywhere around. Same force is experienced. This has mass m. This you take m2 in the expression, and m1 me. Separation between the centers of m1 and m2 is almost radius of the earth, that is your r. Now you convert this relation, F equals to G. Instead of m1 you write me mass of the earth, m2 mass of the body m, divided by re square. Now if I divide, this is gravitational force. If I divide by mass, what happens? Why you have to divide? You do it, then we'll see. F by m, you are just dividing force to the mass which is experiencing the force. What do you get? You get G me divided by re square. Can you identify this, students? Where did you learn? Yes, you learnt last year in relation between capital G and small g. Actually you call this small g. What is small g? Acceleration due to gravity. What is this? Newton's second law. Force per unit mass is acceleration. Force per unit mass is acceleration. Now there is a very important thing, subtle information you have to understand. Tumba sukshma vichara ide enadu. Now if I increase the mass, this mass, will the ratio change? Think of the situation. If I increase this mass according to the law of gravity, force between these two increases, but the ratio F by m is a constant. Why? G is always a constant. What is the value of G? 9.8 meter per second square. Even if I increase the mass, G value will not change. That's what I told you last year, right? When you drop two objects different size, I last year showed a video in which an apple and feather falling, both reached the earth simultaneously. Initially what did you think? Feather being light and apple heavy. Apple reaches earth earlier because of the more speed, and feather later. No, both reach the earth simultaneously. Apple and feather reach the earth simultaneously if there is no atmosphere, air. That's what you saw, right? Means the force per unit mass in this region, in gravity, does not depend on the mass, size, does not depend on the mass. Force per unit mass is always a constant. This is also called by a name, gravitational field. Remember this, gravitational field. What is the meaning of this? You place another mass bit heavier here, force experienced by that divided by its mass is a constant. That is acceleration due to gravity, also read as force per unit mass. Acceleration due to gravity, how do you read? Force per unit mass, which is a constant. Just like how force per unit mass in gravitational field does not change if we change the mass, size. In electric field also, force per unit charge is a constant at that place. What is the meaning of this? I'll rub the students now. You have this idea now. Now come back to this example. There is a charge, big charge in this region. As I explained you with this straw, there is a influence around this, right? Influence around this, all around, that you call electric field. There is influence around this charge. If this is say positive, how do you know its influence? Bring another charge, say some small q. This experiences its force. How do you write that? F, Coulomb's law. F, that is force experienced by this charge is always a constant. Similar to your the law of gravity, does not depend on this value. That is denoted by E. What is E? Electric field. That's what you did there. This is very, very important, students. What is the meaning of this again? Again you see, if I increase this charge, force between these two increases, but the ratio remains a constant. If charge doubles, say, force also doubles. Means if I take 2q, force will be 2F. Ratio remains the same, 2 cancels, it will remain F by Q only. If Q becomes 3Q, force will be 3F. The ratio will be F by Q. What is F by Q? That is electric field. That is electric field, F by Q. Remember students, very, very important. The ratio force per unit charge. How do you read this? Force per unit charge is a constant. It does not depend on the value of this charge, but depends on this. And also separation. We will come to a relation for that. Very important. Now, see in this example, I rub this again. It acquires charge, right? It acquires charge. Acquires charge. Now it has produced electric field around it. This region is said to contain electric field. Now if I bring another charged body, that is a straw, after rubbing, see what happens? See, this is moving away. This is moving away, right? Right? Are you following? With this idea, come over here. If I bring this charge, due to this also experiences force, tends to move away. I have held actually fixed here. That's why it is moving. So, Newton's third law, force on this will be equal and opposite to force on this. Both are same but opposite. That's why in order to produce force on this, so that this is not disturbed, when you bring this charge here, this also produces its own force. One force. That's why in order to analyze this situation, we make this charge very small. Very small is written in mathematics like this. Yes, where did you use this? Limits. How do you read this? Q tends to 0. Q tends to 0 is denoted by Q naught. What is Q naught? Very small. Unit test charge. Unit means not 1 here. Unit charge implies a charge whose value is very small. Unit charge, unit test charge. Unit charge implies, here what is unit charge? Unit charge implies an infinitesimal. Infinitesimal means what? Very small. I write here. An infinitesimal small charge which does not influence, existing field. It does not influence existing field. See, nothing there. There is an influence of this here. If you bring another charge, the influence of this must not change. In that way, if you choose a charge, then that charge is written Q naught. What is Q naught? A charge which tends to 0. Don't look at this strange. Very simple. If you consider very small charge, that is written as Q naught. What is Q naught? In unit charge. Unit means what? Unit is not 1, like unit of mass, kilogram, 1 kg, not like that. It's not 1. It is a very small value which does not affect the force produced by Q. Such a small value, infinitesimally small. Kannada, Sukshma is Sukshma. Sukshma, very small, otherly Sukshma. Right? So, very small value you have to consider. If you consider a very small value, then force of this will not change. That much not altered. That's why we consider unit. But the word small, test here, test. What is test? Actually the name is unit. Oh, understood. What is test? Why it is used? To test whether an influence of plus Q there or no. Right? In order to test the electric field, we use that charge. That's why test. And positive. Why positive? Because there are 2 types of charges, positive and negative. Which one to stick? Once you use positive, give an explanation. Next time you use negative. All the explanations will be just reversed. That's why, to avoid confusions, we always stick to one kind of charge, that is positive. Students, now we have understood why we use unit test positive charge. Unit means what? it must be so small that the presence of that charge does not affect the exit. Already field is there around. That should not be altered by bringing another body. If I bring this here, it moves away. Then this is not unit. It should be very small. Even if it is there, this should not be disturbed. Such a small value. Like a drop of water in front of a huge ocean, right? See, if you put a drop of water into ocean and you will see how much level has increased. No, nobody does, right? Because a drop of water in front of a mighty ocean, negligible, right? That's why a drop of water can be considered a unit. Like that, a charge which is a unit, very small in front of capital Q. How do you write mathematically? Q tends to 0. Therefore, E also written F by, here, what is the E? F by Q naught. And mathematically, if you write limit Q tends to 0, I'll write a bit bigger expression, right? E equals to, how do you write mathematical limit? Limit Q tends to 0, Q naught tends to 0, F divided by Q naught. Why do you write this way? This was my explanation for this. What is that? Once again, you remember this, students? If you consider a charge of considerably large value, that charge also influences Q. This influences Q. It should not influence. For that, you have to consider Q very small. So small. How do you write so small? Limit Q naught tends to 0. If you consider very small value, then force per unit charge is called a field. But if you consider a large charge, what happens? If I consider a large charge, say Q, force will be F dash, some F dash. Force changes that case. But force by charge remains a constant. Like how you explained gravity. In gravity, what did you write? F by m is a constant. That is denoted by G. What is G? Acceleration due to gravity. So, whether you consider a large charge or small charge, force per unit charge is a constant at that point, and that is termed as electric field. Electric field, right? So, now you remember this much. Keep this much in your mind. How do you measure electric field? That's what I mean by definition of field. What is definition? Defined as electric force experienced per unit test positive charge at that point. Why do you use the word unit test positive charge? What is the reason? Reason is, if you consider a charge big Q, a large value, it produces an influence around, that is called field. To sense the field, you have to bring another charge. So you are bringing Q naught to test the presence of field. That's why it is called test charge. Why positive? There are two kinds of charges. We stick to positive. That's it. Positive. That's why this is unit test positive charge. Unit test positive charge. Unit test positive charge. What is the meaning of that? It is so small. Mathematically, how do you write so small? Limit Q naught tends to 0. F by Q naught. Force per unit charge. How do you write? Force per unit charge. Why you write this? To tell you, Q naught is so small. Presence of that Q naught will not alter the effect of Q. Here, Q is called source charge. Q is source charge. And Q naught is test charge. Remember, is there in my notes. Remember this much. What is source charge? Charge which produces electric field is source charge, and the charge which is used to test the presence of field is called test charge. Students, once you write this way, then it's time to write SI unit. That's what you do always. What is SI unit? SI unit of E. Can anybody? S. What is E? F by Q. What is unit of force? Newton. What is unit of charge? Coulomb. So you can write Newton per Coulomb. And once you write SI unit, always you write dimensions. I started explaining dimensional expressions of epsilon 0, E. Will take up in another class separately. You know the unit. What is unit? Newton per coulomb. Here, the meaning itself tells you what is one electric field. Electric field is said to be 1 when 1 Newton force is experienced per coulomb charge. For every coulomb, 1 Newton force is experienced, then that point is said to contain electric field 1 Newton per coulomb. That's the idea, right? Now, because of the explanation of electric field, we can write direction for electric field. It has direction because it is force per unit charge. That's why I write like this. It is a vector. It is a vector. What is a vector? A quantity having magnitude. This is the magnitude, force per unit charge. Direction. Direction same as the force. Force. If charge is positive, means since it is always positive, if this is positive, this means what? Source charge. Then electric field is shown away from this. Electric field outwards from positive charge. If I consider negative charge, if this is negative, then electric field is towards that charge, right?